You can have more results on the internet. And also you can have maybe some results and so that you can share. So for the presenter, you are asked to join. And initially you just set to mute.
Yeah, I would use this camera.
So then you make sure. So then you make sure for group 1 ready. And also you need to set, wow, Prof, you need to serve as a presenter. Of course, for the presenter, don't forget to leave your message online good to indicate you are a presenter. Alright, so that the TA will record it to serve as a bonus for you. And good one, ready? Okay, it's okay for you. And good two, ready? Who will be the presenter? Me. And good three, you. It's you. And be prepared so that later you will have the content to share. And good four. Ready? Or maybe later you can have your own content. So first of all, good one. So you can turn on your microphone. I will pass microphone to you as well. I mean microphone of Skype. Okay, that's good.
Can you see my screen?
Why? Wait a moment. Yeah, this one, right?
Yes.
But how to tune so that it will be clear. Okay. Currently I'm mute. So mute. But for you, no. You can turn on your microphone.
Alright. Can you keep it there?
Yeah. Oh. Forget it.
Okay, so can you hear me? Okay, so scattering happens when an incident wave usually encounters an object that's smaller than the wave itself in its path.
So you can see it out.
Okay, and then it deviates into multiple directions when the initial wave hits the object.
And then?
And that's it.
Oh, that's it. Alright, so this is a picture to indicate what's scattering. So scattering from good one. Okay, thank you. And scattering from the other good. Good three, right? So ready? Same, share your screen. Let me share. So you need to share your screen so that it can be shown on the main page. You try to turn on your microphone first. Okay. Maybe it's still okay. Oh, with echo, so you set to mute. Okay. So ready? Okay, go.
So in the context of propagation mechanisms.
You can speak louder.
So in the context of propagation mechanisms, scattering refers to the phenomenon where waves are deflected from their original paths to the direction with including obstacles to the medium they are traveling through, causing them to spread into multiple directions. So the important is like scattering is important factor in understanding how waves propagate through different media, as it can affect signal strength, distortion, and the overall characteristic of the wave. So the examples are like radio waves that it can be scattered by tree, buildings, or other objects that can cause radio signals to bend and spread, allowing them to reach areas beyond the line of sight. And then light can be scattered by particles in the atmosphere like dust or water droplets, causing the phenomena like the blue color of the sky or blurry image in fog. And then sound can be scattered by particles like walls or furniture that can cause echoes and reverberations. Okay, that's all.
Okay, thank you. So this one actually, you asked ChatGPT to prepare the content for you, or the other AI? Okay, so at this. Actually, this is a presentation from Group 3 talking about scattering. Actually, initially we have Group 1 to illustrate a picture, show that, oh, okay, we have the incident where, and so that how to have the scattering. As for the details, actually, we have some details provided by Group 3. Alright, so this is scattering. And the next one, diffraction. So, Group 2, diffraction. And share your screen first. And initially turn on your microphone and then turn it on, and so that you can show your content first. Okay, that's it. So right now you can set it to mute, and so that if you are ready, then go. Speak louder.
Okay. Diffraction is when the wave, light or sound hits an object, and you will, let's say you will produce like another wave around those objects, and that is diffraction.
So any constraints for the current object, or maybe we need to have some special arrangement to have the possibility of diffraction.
I'm not sure.
Okay, I see. Okay, that's it. Thank you for presentation from Group 2. And how about further discussion about diffraction from Group 4? Sam, share and try to turn on your microphone, but finally turn it off. I saw that you can show. Yeah, that's correct. And turn it off. Yeah. So presenter, ready? Go.
Okay, so from this image we can see that diffraction is a phenomenon of happens to any kind of wave. It can be either light, radio wave, or etc. So diffraction, as you can see here, it bends. That's like as you know from light, light can diffract when it enters water, right? So this basically has a similar principle. So in diffraction, you help. However, to make it happen, you have to hit a sharp edge, for example, like the edge of a building. That way, the wave will bend either towards down or up to the ground, and it will and from there actually this has a bit of benefit for us. So for example, this will enable us what we call a non-line of sight for any kind of application, whether it be radio waves or etc. So however, the downside of this diffraction is that usually diffraction like this often reduce the intensity of the wave, making it so it will be in a weaker signal than using a direct or a reflection wave.
Okay. Alright, thank you. So we have the discussion from 4 presenters. And right now, if indeed we have the activity of Jigsaw. Then some of you need to move. So maybe I try to ask one of you move to a different group. So you talk about scattering, right? So anyone want to move to a different group so that they can share the meaning of diffraction from a different groups. Or maybe let me try to ask one move to group 2 and the one move to group 1. So can you move to group 1 and maybe one of you move to group 2. So anyone want to exchange? Okay, sure. Yeah, because he is a presenter, so you need to and go to group 1 and you go to group 2. Alright, so for all of you can continue to have further discussion about here scattering again and there diffraction again. And later you will think, okay, we understand that or not. And for group 4 and maybe 2 of you move to group 3. Alright, we talk about scattering. Okay, you talk about diffraction, right? So maybe 2 of you presented and you still stay there for the others to this group. And 2 of you go to group 4. And you have 5 minutes again to have a discussion talking about this. Sure, it's to finish the discussion about scattering, we will share about diffraction. opinion with the other members? If yes, then you can return to your original seats. Okay, thank you. Actually, next time if you can show your standing page and then you will know each other easily, right? Standing page and put it to a different group. But this time maybe no, but that's okay. You can know each other by asking the names of the possible members. Alright, so this is the so-called activity jigsaw. Jigsaw originally from jigsaw puzzle. That says we have many pieces and we need to put them together so that you can know the whole maybe time or something else. Well, so maybe I turn it off, so if you want to join again, then you can scan the QR code again. If no, maybe no. So let me move on to the current one. So I mean, you have the discussion about diffraction and scattering. And for all of you, you can look at the two items again, and same as your understanding for maybe 1 minute. Diffraction, scattering, identical to what you learned from the other methods. Alright. So you can check it. I just try to repeat the content shown on the slide. So scattering first, right? Objects smaller than the wavelengths, smaller than wavelengths. For example, foliage, street signs, then posts. And then if we have the incident wave, so we don't have the regular direction. Therefore, we have the scatter wave to a different direction. So it is called the phenomenon of scattering. And diffraction here. Alright, diffraction, right? So same, we have the irregular edge and sharp irregular. Alright, and actually 1 from good 2, he say if we have some irregular edge, but maybe we have some here, and so that it will bend the web, and so that we have the phenomenon of diffraction. Alright, so these are diffraction and scattering. Of course, later we will have some image to show these again. But reflection, maybe it's easy, so none of you to have the presentation about the reflection. Reflection, someone like, oh, okay, I have a wave, and it impinge on an object, and this object is really large, and so that we can have the reflecting wave, and then it is called the reflection. Alright, so these are the propagation mechanism. I think after the activity at least you learn diffraction and scattering. And also, I didn't know the reflection because the reflection is a common one and the easy one. So I think for the 3 mechanisms, you know them already. Alright, so for all of you, you have the 3 items. And don't forget to leave a message on line group to indicate you are a presenter for the 4 presenters. And you will receive 2 points to have the bonus. And the next one, even we don't know we have enough time or not, but right now, I think now you check the problems, right? So you have time to check it. And we have a problem from chapter 1, so it's problem 1 point. Problem from chapter 1. And the 17th problem. And the problem talking about this. So we have A and B. So take a picture first, yes. And suddenly have the problem. Even after classes, you need to check the problem again, but I ask you to take a photo to have the problem set first. And for the 2 problems, of course, you need to reply. Okay, you need to answer for all of you, 1 and 2. But right now, I will assign some of our members to talk about and share the answer later. So the first problem, 1.17, A. So assign to good 1. Focus on A only. And B, by good 2. 1.17B by good 2. And the problem here, first of all, Q length by good 3. And, not Q length, system size by good 3. And system waiting time by good 4. Alright, so right now you can think about the problem and then you have 5 minutes to prepare the answer and later we can share. After sharing, finally we will ask you to upload your answer. Perhaps it's quite long, so same, you can write it on one A4 page and send the photo to line group possibly. But maybe not right now. First of all, prepare your answer. Group 1 to 4, prepare your answer, and 5 minutes later we will ask you to share. 2 problems by 4 sub-problems finished by group 1. Group 1 ready? 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 Okay. And group 4 ready? Not yet. Okay, you can continue. And group 2 ready? Okay. And group 3? Okay. So maybe 4 you can continue. Let me proceed the discussion from group 1, 2, 3, and 4. So again, let me start the Skype. So presenter join at least. And then initially while you join and share the screen. And try to share so that you can occupy the main page. 10 items. Correct. And you're ready? Okay. Who is the presenter? So if you are ready, then go.
I use the total bandwidth because it's FDMX, and we use the total bandwidth to DVD the cell 515 DVD hertz, kHz. So we use the total bandwidth to 13.3 hertz to multiply the this is total bandwidth, and DVD DVD 15 to get 616 channel. So we reserve the one control channel, so probably we have 659 channel, and this is what we reserve.
All right, thank you. So for a while the answer, maybe still stay there. The answer. Show the answer again. And all of you can take a picture because I asked all of you need to talk about the answers for problem 1 and 2. So keep the answer from the other groups. All right. Okay, but just for your reference, correct or not, it's up to you. Okay, so this is a rough answer for group 1 and group 2.
Yeah, so I can also show my
Sure. You can ask him and show your answer.
Yeah, but basically, I just started writing it down because I can also explain it. It's not that complicated.
Oh, sure. Wait a moment. Try to start the microphone and so that maybe. Yeah. And turn it off.
Okay, so basically, as the first group already.
You can speak louder.
So as the first group already explained, first we need to transform the megahertz to kilohertz and then divide it, which was correctly. And so for the second part, we not only want to use the frequency bandwidth, but also thread it through 8 multiplexes, which is basically just multiplying the 660 from the first.
Multiply 8.
By 8.
Yeah. So the answer from Group 2 says the answer should be times 8, so that we have a channel using TDMA, right? Multiplexing. Okay. So this is the answer from Group 2.
Yeah.
Okay, thank you. And here for the answer, he said the answer on B should be 8 multiply the original answer from Group 1 for your reference. And then it's Group 3, same. Shall try to turn on microphone but turn it off immediately, and so that we won't have echo. Speak louder.
Okay, so the change in the average number of customers in the system, LS, when the arrival rate and service rate are doubled in an M1 efficiency queuing system. So the answer is that LS remains unchanged. We can see here from the formula, the step 1, the original utilization rate is that formula, and when we calculate the LS, the result is lambda over mu minus lambda. And then on the step 2, we calculate the new LS, which is also the same with the previous LS. So on the step 3, we compare the previous LS and the new LS, which is the same. So the conclusion of our answer is that LS remains unchanged.
So thank you again. For all of you who can track, oh sorry, you still remain on that page. Yes, you can take a picture first, so that you have the reference answer. You can judge correct or not. Why? I don't have the concrete answer because I ask you to think about this. And finally, you need to have your own answer on Paul everywhere or on our line group. But you need to write it for yourself. All right. Let me finish the final discussion, but maybe next time I ask you to have the answer on Paul everywhere, but not this time. But at least you need to collect all the answers. So final one from Group 4. Share your screen and turn on microphone, but turn it off immediately. Correct. So, ready? So, presenter.
So, for the first problem, we have the average number of customers in the system. It's really simple formula. We just multiply it by 2 and find out that it divides itself, so it remains the same. And for the second problem, we just multiply it by 2, and which means we can separate it, and it's like half of the dwell time of customers, which is original. So that's it.
So change your remain unchanged or changed for your sub-problem.
So our sub-problem is the average dwell time, and it halved.
Halved.
Yeah.
All right, halved. Same, take a picture and then serving us your solution. All right, thank you. So this is the answer from Group 4, and finally, you can take a photo first. All right, and keep all the answers and try to reorganize. And next time, maybe it's easy for you just upload the photo to the whole algebra system. But you need to say something on. You need to say something on our whole algebra. Oh, okay, I have my own answer online group, but not this time. Next time. So not today. Next Monday, I will ask you to upload your answer to Paul everywhere or whole line group. Alright, that is this is a possible answer. Possible answer. If you don't think it's correct, you can change it. Alright. If you don't think it's correct, you can change it. You need to have the answer for the 2 problems, but 4 sub-problems for each, and so that you can know for all the details of the problems. If any question, you can discuss with your members for sure. But finally, you need to have your answer for the 2 problems. Alright, about this, any questions? Do not upload right now, just next Monday. Is it okay? Or otherwise, our TA cannot find it. Alright, that is, we have a jigsaw activity, but we just finished some of group discussion 1. And next time I will ask you to upload answers, so don't worry. Alright, before you go, let me ask you any questions? If no, that's it. And see you next Monday. Okay, bye bye.